Yes. 32. On 530. A bird species in danger of extinction has a population that is decreasing exponentially. And we know A of t is 0e to negative kt. It's given to us. 5 years ago, the population was 1,400 5 years ago. And today there are only 1,000 are alive. Once the population drops below 100, the situation will be irreversible. When will this happen? Okay. 100 it becomes irreversible. So if we don't take care of the this species soon, in other words, if they drop below 100, we can extend their life. They will go extinct. Okay, so basically we are given 2 points here. So let's see how we create these 2 points. We can start our initial population at 1,400. So I'm going to say that the initial population is 1,400. And let's say at time 0, there were 1,400. And that's 5 years ago. Today, 5 years later, the population is 1,000. So the initial count, the initial value is, it happened to be 5 years ago. That's fine. So at time 0, we have 1,400. Now 5 years later, which is today, we have 1,000. So in the model, I would plug in this first point. I don't really need to, because when I plug in 0, I get 1,400. But let's say when I plug in 0, A of 0 is 1,400. That's what this point is telling us. A of 0 is 1,400. So 1,400 equals A0 times e to negative k times 0. But this is 0. E to 0 is 1. So we know that the initial value is 1,400. So then the model is 1,400 e to negative kt for now. I need to determine this. And that's where the second point comes into play. The second point says that A of 5 equals 1,000. Okay, exactly what we did before. So I have 1,000 for A of 5 equals 1,400 e to negative k times 5. And again, when you see the pattern, everything is all the same. First, I have to divide both sides by 1,400. So 10 divided by 14 equals e to negative 5k. Again, like before, you see the pattern. I have natural log of 10 divided by 14 equals negative 5k. And then we find that k equals natural log 10 over 14 divided by negative 5. So with a calculator, natural log 10 divided by 14 and divide in parentheses by negative 5. And I got 0.06729. So now I have the entire model. A of t, 1,400 e to negative 0.06729t. No more secrets. This is our function f of x equals whatever. So now they're saying how long we have to save the species, because if we allow them to drop to 100, they will die out. The question is really asking us how long it takes to get, how long we have till they will drop below 100, and then we're done. We can't do anything to save them. So that really means that when this is 100, that's how long we have. And let's see how long we have to save the species. Again, I divide both sides by 1400, of course. I apply natural log. And I divide by this. And let's see. I hope we have some time to save them. So natural log 1 divided by 14, close the parenthesis. Don't forget to put parentheses if you are using a negative, or you keep in mind to put it in at the end. But okay, we only have 39 years, 0.21. So we'd better hurry to save the species from extinction. Any questions? As I said, there are very, very interesting situations in this chapter. Is I would say one of the most colorful when it comes to different situations, different models, different applications in real life situations. It's widely used. Okay, we have left, what do we have left? We have left 5.1, 5.4, 5.5, 6.1 and 8.1. So these are the last 5 sections of the course. So let's talk about chapter 5, which deals with systems of equations and inequalities. You've seen this before, this is not new. I'm going to copy a problem from the book because I have a few things to explain. We are going to look at 2 methods, substitution and elimination. But I just want to copy a problem from your book, like let's say problem 8, 555, and I'll explain everything we need. Okay. So first of all, what is a system? So let's talk about the title. We know what equations are, we know what inequalities are, but what is a system? A system is when 2 or more conditions are put together. They must happen at the same time. So in this case, we're going to be looking for an ordered pair that verifies both equations. If it doesn't verify both equations, then it's not what we're looking for. First of all, these are 2 lines. So what can happen when we look at 2 lines? Situation 1, situation 2, situation 3. In situation number 1, this is the first line, and this is the second line. So they do have a solution. We call the system consistent. And the equations are independent equations. And there is a solution. Second situation is when this line and this line are parallel. They never have a solution. They will never intersect. And we'll say that it's an inconsistent system. And we have no name for the equations. They are parallel. Parallel, if you want, lines. And there is a third possibility in which one equation is this, and the second equation is this. Of course, the system is consistent. The equations are dependent. It's a consistent system, and it has infinitely many solutions. Infinitely many solutions. How come? Well, two straight lines can only meet in one point, or in all. So we have this situation, or we have this situation. We can have two. Two straight lines cannot meet in 2 points. They either meet in one single unique point, or they meet in 2 points. Or they meet in all. They can never meet in two. Either all, by overlapping, they are the same equation, or one. They can never meet in two. Okay, so knowing that, now let's refresh our memory on elimination and substitution. They're not the same. These are two methods. Now, we've applied this in several word problems, I think, in the past. I'm looking at the second equation and I see it's already solved for y. In other words, I'm told y is the same with 2x plus 7. If y is the same with 2x plus 7, it means that this y can be replaced by 2x plus 7. Why would I want to replace y in the first equation by 2x plus 7? First of all, because y and 2x plus 7 are the same. Secondly, I don't know how to solve an equation with two variables. When I remove y, basically because I'm replacing it by 2x plus 7, I will be able to solve for x, and then I'll come back and solve for y. That's not a big deal. So let's do just that. I'm going to copy the system here one more time. So 2x minus 3y equals negative 13, and y is 2x plus 7. And then I replace in here. So the first equation becomes this. This I know how to solve. I will distribute. So I have 2x minus 6x minus 21 equals negative 13. Yes, I'm going to add these two, negative 4x, and I'm going to add 21. So 21 minus 13 is 8. So then x equals negative 2. Is it done? No. No, it's not, because I have to find y. I go back and replace here. 2 times negative 2. So then y equals negative 4 plus 7, or y equals 3. I claim that the ordered pair, the only solution of the system, because it's this situation, is negative 2 comma 3. And you have to say, I don't trust you. Not that you don't trust me, but you're going to say, please show me why. Okay. So we go back to the original problem. We replace x by negative 2, and we replace y by 3. And make sure that everything works perfectly. This is negative 4, and this is minus 9. Negative 3 times 3. Negative 4 minus 9 is indeed negative 13. Here I have 2 times negative 2, which is negative 4. Negative 4 plus 7 is indeed 3. I don't need anyone to tell me that this is the only solution. Yes, I checked. It's the only solution of the system. And that was the method of substitution. We have time to look at one other example with elimination, and Wednesday we'll have more examples of both. So, a simple one with elimination. I'm looking at number 20 on the same page, 555. In number 20 we have x plus y equals 6 and x minus y equals negative 2. I can put this away for now. Yes, sorry, yes. Yeah, when I have the book in my hand and at the same time I'm trying to write, sorry about that. Okay. So, well, when we try to use elimination, so this was the method of substitution. Y, we substituted y in the first equation by this. Here we're trying to eliminate one of the variables. Well, you can say, well, that's exactly what you did. By replacing y by this, you eliminated one of the variables. True. That's correct. Basically, it's the same thing. But here it's a slightly different way of doing it, but the same idea. So I look at the coefficients 1, 1, and positive 1, negative 1, and I say, this is it. And I also see that they are opposites of each other. Why don't I just add? X plus x is 2x. These will go away. I copy the equal symbol, and here I have 4. And I know that x is 2. Dividing both sides by 2. Is this enough? No. I have to go back. Let's say I'm going back to the first equation, replacing x by 2. So I have 2 plus y equals 6. When I solve for y, I get 4. I claim that the ordered pair is 2, 4, but you can also say, and we should always say, show me. And I will show you that 2, 4 works. 2, 4, 2, 4. 2 plus 4 is 6? Yes. 2 minus 4 is negative 2? Yes. So now there is no doubt that this is a yes. I check.